taking a square root. Now, the good news is that this is super simple. The bad news is that this is limited to when it will work. So this will only work, okay, when we only have x squared, okay, which means we don't have an x to the first power involved. So it works when we only have an x squared. So maybe we have something like x squared minus 9 equals 0. So if we look at this, right, we see an exponent of 2 on an x, but nowhere do we have an x that has an exponent of 1. So when we go to solve these, we are going to do basic equation solving. Remember when I told you like PEMDAS is the biggest lie you've ever been told, right? Because we really need that, why do I keep writing R? We really need that R in there for inverse operations. And that's exactly what we're going to do. We're going to solve this just like a regular equation, but we are going to understand that a square root will undo an exponent of 2. So if we want to solve this, we're going to inverse operations. Okay, so we'll undo addition and subtraction. So we undo subtraction with addition. And whatever we do to one side of the equal sign, we also have to do to the other. So those two will cancel out. And we will be left with an x squared equals, and then 0 plus 9 is 9. Okay, then our second step will be to undo an exponent of 2. To undo an exponent of 2, we add a square root. And just like everything else, whatever we do to one side of the equal sign, we have to do to the other. Okay, so since exponent of 2's and square roots are inverse operations, they cancel each other out just like this subtracting 9 and adding 9 did. So those two things just cancel each other out. The square root of x squared is just x. So we are left with x. But now we have this new dilemma we haven't talked about before. The square root of 9 is 3. And up until this point, that has been good enough. Okay, the math definition says the square root of 9 is the positive option. However, this problem didn't originally ask us for a square root. We used the square root to help us solve, which means we need to consider the fact that 3 times 3 is positive 9, right? A positive times a positive is a positive 9. But so is a negative times a negative. So negative 3 times negative 3 is also positive 9. And so we represent this in the math world by writing this symbol. Okay, it's a positive over a negative. And we read this as plus or minus 3. And it says that we really have two answers. X can equal 3 or X can equal negative 3. And we actually get two answers. Now, you could write your answer either way. Either of those options are fine. The plus or minus symbol is accepted in the math world. We see it all the time. Okay, so we get two answers of 3 and negative 3. So now that we know that info, we're kind of home free. So let's say we have something that says 2x squared minus 72 equals 0. Okay, and we want to solve this. So we will regular inverse operations. We will undo subtraction with addition. Okay, so now we have 2x squared equals 72. Okay, but now we have this 2 sitting in front. Okay, so our next step is that we need to undo multiplication with division. So those 2 cancel. And then we will undo our exponent of 2 by square rooting. And since we added that square root, right, the square root of 36 is 6, but because we're solving an equation, it's plus or minus 6. Two answers. X could be 6, X could be negative 6. Okay, let's look at another one here. How about x squared minus 1 equals 39. Oh, and you see my cat feet in the picture probably there. Nope, And she's climbing on my computer. One moment. So if we want to solve this, I'm sure you were all hoping you could see cat appearances in this video. If we want to solve this, okay, still inverse operations, we'll undo subtraction with addition. And we will undo our exponent of 2 by adding a square root. Again, we added the square root, so we need to add a plus or minus. The problem here is that the square root of 40 is not a perfect square. Okay, so now we're here. But we can't circle this and say that this is our final answer. Your math is fine, you're not wrong, but you are not done yet. Because the same thing we have been talking about every day is that our answer always needs to be in simplest form, which means we need to take this square root of 40 and start simplifying it. Right? So we prime factor. So that gives us a 2, a 2, a 2, and a 5. And then we are going to look for any pairs. So we have a pair of 2s. So whatever's our pair comes out in front one time, right? 2 shoes, 1 pair. Whatever's left stays inside and we multiply it. And we can't forget that we have this plus or minus symbol in front. So we'll get a final answer of x equals plus or minus 2 square root 10. Now, if we can't simplify it, that's okay. Okay, so it's okay if we have something that says x squared minus 3 equals 0, right? And we start solving, and we square root, and we're like, oh, I try and prime factor, there's no pairs. So that's okay. This is already in its simplest form, and then we would just have x equals plus or minus the square root of 3. Okay, so again, it's just checking to see if it can be simplified, and if it can be simplified, we need to get it in its simplest form. Last problem for this one. How about 2y squared plus 18 equals 2? Again, just how we solve equations. So I'm going to undo addition and subtraction first. That's nothing new. Then we will undo multiplication and division. So I'm going to divide by 2. And then I'm going to undo my exponent of 2 by square rooting. Okay, so we need to think of a number times itself that gives us -4. And a lot of times my students will say too, oops, I'm hitting my table. Sorry if that's shaking. So we'll say, okay, well, let's take the square root of -4. And our calculator says error, because there is not a number times itself that gives us a negative, right? We would need one negative and one positive, and then it's not a number times itself. So whether it is step 1, step 2, or step 100, if you ever get to the point that you have a negative underneath the square root, you are stopping everything that you are doing, and we are saying no real solution. Now this real in here is really important because that's the real number set. Okay, there is a solution